Hello everyone, my name is Dustin, as you right now. Today we are going to be reviewing some recent things I've been doing with my language. Right now I have been working on some other rules inside of my language, and I just wanted to kind of discuss that today. So yeah, if you didn't know, last time we went over something with my language, an example I made with my language. Last time we did Rule 110. And that was great and all, but as it turns out, what I was doing was elementary cellular automata, which used three kind of bits and then placed one in the middle to make stuff like this. And as it turns out, there's a whole bunch of rules that you can actually make, as you can see here. A lot of these look really, really cool. Like Rule 150. Last time we checked out Rule 110. If I click here, this sequence generated, blah, blah, blah. Rule 110 has the perhaps surprising property that it is Turing complete and capable of universal computation. And that's exactly what I wanted to show off last time. But since then, I've kind of started exploring a bit what all you can really do with this. But as it turns out, there are a lot of different elementary cellular automatas. Let's see if I can find which one I was doing. There was a website I saw on this. I think it was this one, but I'm not entirely sure. There was a website where I could just click on it and it would show me all of them. Maybe it was in sources here. Yeah, here we go. Okay, this is the website that I started reviewing. I just wanted to see like what all there was to explore. And you've got some interesting ones like this. And like this. Another cool one, this one. But I decided to review this one, 126, because it looks pretty cool. But that's besides the point. The point is I implemented it in my language. If I go to examples and run this, it's got a bit of a cold boot, just because I just started up my computer. And this is what it looks like. It generates kind of a big triangle. And if you're wondering why this one looks a lot cleaner than the previous one I was doing, if I go back to my YouTube video, which is we ever one. The reason why it looks a bit cleaner is because here we're using arrays to output stuff. So if it zooms in a little bit, there's spaces in between each of the numbers there because we're using arrays. Here I decided that strings would be a bit better for outputs, just so you could do like a huge amount of them. Like here, that's probably like all I would have been able to fit in the previous one, but I made it a bit better. So let's review the code real quick for this. We got the cellular automata length, and I decided to use strings for this just so I could show it off a bit cleaner, I'd say. Then we fill an array with dead cells, or we don't use an array here. Fill a string with dead cells, and then we can add an alive one at the end. Here I decided to divide by 2 on the automata length, add 1, and then go again, just so it starts in the middle, so you get the full picture of what this rule does. So here's what it'll look like if I were to do like a length of 5 maybe, or 6. It would put 1 in the middle. Then it would add 1 at the end, and it prints it. Now, one thing with strings, it's a bit weird because I'm using Go. I'm translating my code to Go. And when you index a string in Go, it gives you a byte instead of the string. So you can't really like convert it to a string. But what I can do is do a little workaround, and I can actually just translate the dead string, that character there, and the alive string, that character there, and actually just use those bytes instead. Took a bit to figure that out, but I did. Then for the automata length, divided by 2, because in this it kind of like writes double for it. You can write it off. Then we start off the string with dead cell. That way it reads it properly. Then for the width, we're setting the analyze to an array of bytes, which is what we're analyzing with the dead byte and the alive byte. And another refactor from last time, I decided that instead of just using a bunch of else ifs for analyzing each of the individual rules for it, what I could do is for each of the ones that put 1, so if I go to 126, since there's 1, 2, 3, 4, 5 rules that make the cell alive, what you can do is you can actually just do 2 rules with if and else if, and then just put the rest of them in else, because that way your code, you don't have to analyze like every single rule. It's a bit faster, I'd say, and you definitely don't have to write as much code, so it's way easier to read. So there's only 2 rules that that actually are dead, and that's if it's all clear and it's all alive. And we can see that here: dead, 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 alive, alive, alive. And then we append a dead string to our current string, and otherwise we add an alive string to our current string. Then we append a dead at the end so it can analyze it properly, and we set the init array to the new, or the initial string to the new string, and print the initial string. And what I can do here is actually just print the new one and then set that, just so we get the output a bit faster. And as you can see, prints it very nicely and quite fast, if I might say. I don't know the exact time, 80 milliseconds. Yeah, that's pretty good. So yeah, another thing I'm beginning to work on is Leetcode. I'm starting to do Leetcode problems in my language, just to see if I can get the proper outputs and whatnot. So if I go to leet.sus, this is the toSum. This is Leetcode 1. Oh god, it's light mode? Ew. So this is Leetcode 1. If I click on this, our expected output is that, and if we use the example test cases, uh, 0, 1, 1, 2, 0, 1. You might be wondering if that's like just me outputting it, so I can assure you I am using toSum. From my language, I'm using the function. There's a target, there's numbers, and check if one is equal to the target from an addition. And as you can see, it works perfectly. So yeah, that's what I've been doing so far with my language. See you next time.